question number 9, I'm trying to find the intersection point of the two graphs. And I'm doing it by the substitution method. So my first step is going to be to isolate for one of my 4 variables. And I'm going to choose to isolate for the top y. So I'm going to divide both sides of that top equation by x. So y is equal to 3 over x. And then I want to plug that into the other equation. So I have negative 2x plus, and I'm substituting in the 3 over x. So now I have an equation with fractions. So I have negative 2x over 1, you could call it, 3 over x, and technically 1 over 1. So I want to get rid of my fractions, so I want to multiply by the LCD of all 3 of these, and that is x. So I'm multiplying each fraction by that LCD, which is x. And that leaves me with negative 2x squared plus 3 is equal to x. So I want to get everything onto one side and 0 on the other and then solve by factoring. Or you could use quadratic formula. So I'm going to move everything to the right so that my x squared is positive. So 2x squared plus x minus 3 is equal to 0. And then if you factor that, that's going to be 2x plus 3 and x minus 1. So I want to set both of those equal to 0 and solve. So x is negative 3/2, x is 1. And then I need to plug those back into one of my original equations to figure out what the corresponding y values are. So I'm going to plug them into this one. So y is equal to 3 over negative 3/2, and y is equal to 3 over 1. So with the first one, when you're dividing by a fraction, it's like you're multiplying by the reciprocal. So this is actually 3 times 2 over negative 3. So those 3's cancel out and you're just left with a negative 2. So your answer will be negative 3/2, negative 2. Up here, 3 over 1 is 3. So that answer will be 1, 3. And if you check them both in the original equations, they both work. So these are my 2 intersection points.